Hey everyone, this is 4.3, adding and subtracting rational expressions. Think back in your mindset, back when you were in elementary school learning fractions for the first time, and they asked you to add fractions. The one rule that we knew about fractions was the common denominator. They had to have a common denominator in order for them to add. So when you're doing adding and subtracting rational expressions, the same situation applies. So when we look at this problem, it says 1 over n plus 4 over n. I'm circling my denominators. The denominators are both n. So because they are both n, you're going to say 1 plus 4 over the common piece. So if they are the same, the common piece is on the bottom. The numerator, because there's a plus sign, I put them together, so you end up with 5 over n, and you are finished. On the next example, when I look at the problem, it says 2x minus 1 over x plus x minus 2 plus 1 minus x over x minus 2. Again, I am circling my denominators because that's what's going to tell me if I can immediately add together. Since they are the same, I know that x minus 2 is the denominator line. Numerator line, I see a plus sign between them, but because of that, I don't, rules of factor, adding additional pieces, I'm going to write 2x minus 1, and I'm adding in 1 minus x. I put them in parentheses in case that plus sign happened to be a minus sign, which you then have to distribute. So when we look here, we have 2x minus 1 plus a 1 minus an x, still x minus 2. So the reason I did this is because I want to be able to combine like terms in the numerator line. When I look at the top, negative 1 and positive 1 cancels out. I had two x's and I took an x away. I'm left with an x and then x minus 2. That is your final product piece. On to the next example. Think of the last one we just finished doing. I said in case there was a minus sign in between, you wanted parentheses around the numerator. So first thing, we're looking at our denominators. They're both 5x squared. So 5x squared is the bottom piece. I'm going to write 2x plus 8. There is a minus sign. And then I'm going to stick 9x plus 8 in parentheses. And the reason about that is because this negative sign has to distribute into the second parentheses. So we see 2x plus 8. Now it's negative 9x, negative 8. 5x squared. Again, we do what we did on the last one, combine like terms. I see a positive 8 and a negative 8, which cancel each other out. 2x spent, I had $2 and I spent $9. I am short 7 x's over 5x squared. Here's where we need to simplify one step further. Notice that there's an x on top and 2 on the bottom. If you do not see it, you can split it saying negative 7x and then 5xx. So we can see 2 x's where a pair of them cancels out and you're left with negative 7 over 5x. So when we started this set of questions and examples, we started out with common denominators. Well, what happens when you don't have a common denominator? Well, when we look at this example here, it says 1 over x plus 5 minus 1 over x plus 8. So just looking at the denominators alone, they are not the same. So we need a common number. So we need an LCD is what we're looking for. When we look for our LCD, because these are parentheses around both of these, that is your LCD. So x plus 5 and x plus 8 are part of your denominator common piece. So what we're going to do is we're going to take our original problem. And we're going to make sure that we're converting these fractions to have a common LCD of this. So we're going to do a fraction bar. We're going to write x plus 5, x plus 8, minus sign, fraction bar, x plus 5, x plus 8. So in order for x plus 5 to become x plus 5 times x plus 8, we had to multiply top and bottom by x plus 8. So I see 1 times x plus 8. And the reason I'm doing this is in case that value of 1 actually happened to be a 2, a 3, a 20, and then we would have distributive property occurring. For x plus 8 to become x plus 5, x plus 8, we had to multiply top and bottom by the missing part, which was x plus 5. So again, the 1 times x plus 5. So now that we're at this situation, now I can notice that the denominators are the same for both of them. There's a minus sign in between. So I'm going to draw one fraction line, x plus 5, x plus 8, 1 times x plus 8, minus sign 1 times x plus 5. I am not doing any distributive properties yet. I just wanted to group my pieces together. Now we're going to distribute in case, remember what I said, in case this happened to be a value greater than 1. So we're multiplying in, and here we're multiplying a negative in. So we get x plus 8 minus x minus 5, x plus 5, x plus 8. Combine your like terms. Well, positive x and negative x cancel out. I had $8, but I spent $5. I have $3, and then x plus 5, x plus 8 slides over. Moving on to the next example. Again, on this one, when we look at our denominators, it's a squared minus 1, a plus 1. They are not the same. But I noticed that a squared minus 1, remember, this is your difference of squares. So that breaks down into a plus 1, a minus 1. Which, when I look here, this has part of this piece here. So our LCD in this situation is going to be a plus 1 times a minus 1. Again, we're going to start out with our original problem. But instead of writing a squared minus 1, I'm going to use a plus 1, a minus 1, the factored form. And then I'm going to write my new denominator that I want. I want it to become a plus 1, a minus 1, a plus 1, a minus 1. Now, the first fraction already has what we want. So we have nothing to bring down. All we're going to do is bring down 8a because it was already with our LCD. The second one is missing the a minus 1, which means I'm multiplying top and bottom by a minus 1. So I'm going to write a times a minus 1. Since the denominators are the same, one fraction bar, a plus 1, a minus 1. We have 8a plus a times a minus 1. I wanted to group my pieces first over a common fraction. Now we're going to apply the distributive property here. So we have 8a plus a squared minus a over a plus 1, a minus 1. Okay, we need to put this combined in decreasing power, so a squared had to come first. Then we had 8 apples, and I ate an apple. I still have 7 apples. A plus 1, a minus 1. When we look at this, yes, we can factor out an a out of the top one, and it just becomes a times a plus 7, but that does not allow us to cancel with anything in the bottom. So your final answer is going to be a squared plus 7a over a plus 1, a minus 1. Next example. So in this one, making it a trinomial for our denominators now. So again, look at our denominators. They are not the same. First thing we have to do is factor them before we can do anything. So I'm looking at my bottom pieces. Numbers that multiply to 1 that add to 2 are only 1 and 1. So this is x plus 1, x plus 1. Numbers that multiply to negative 4, remember we can be 2 and negative 2, but when I add those it gives me 0. Or 4 and 1. To give us a negative 3, the 4 had to be negative and the 1 positive. So when I look at this, we can figure out what our LCD is. Now remember, in order for an LCD to occur, you need one of every piece. So in this situation, I need x plus 1 twice, because remember, it's the highest exponent power. There's 2 of these to the 1 on the right, and our x minus 4. So we need 2 bubbles and then the single one. Remember, if it's a power of 2, you have a power of 2 compared to a power of 3, the power of 3 is going to win out. Same thing with a power of 1 to a power of 2. So this is what our denominator is going to be. So, okay, so we're going to make our fraction. So our original, so we see x plus 1, x plus 1, x minus 4, x plus 1, and then what we're wanting it to become. So we want it to become a 3-piece denominator, so it's x plus 1 twice with an x minus 4. Again, x plus 1 twice with an x minus 4. Now remember, we are giving it what it was missing. When we look at the first one, x plus 1 is missing x minus 4. So I'm multiplying top and bottom by x minus 4. So we're going to write 1 times what I was missing. The other way to remember is that if you put your fingers over it, it cancels out and you see your original fraction you started out with. When we look at the next one, x minus 4, x plus 1, I'm missing another x plus 1. That is what I'm multiplying top and bottom by. So 1 times x plus 1. Since our denominators are now the same, we're going to write one common denominator. So x plus 1, x plus 1, x plus 4. 1 times x minus 4. Remember, there's a minus sign. That's why we put everything in parentheses. So we have distributive property occurring. So on this one, we're going to distribute in case that value of 1 happened to be another number. So we have x minus 4 minus x minus 1, x plus 1, x plus 1, x plus 4. Combine your like terms. So x and negative x cancels out. I'm short $4. I'm short another. I'm short 5 over x plus 1, x plus 1, x plus 4. You can leave your answer like this or as negative 5 and then x plus 1 to a power of 2 with x plus 4. Either or is correct. Next example. So in this one we have 3 fractions, 3 fractional expressions that we need to add. So first thing we need to do is factor denominators. So this piece here becomes x times x plus 3. That's still x, and that's x plus 3, which if we notice that they all have, these two have parts of this one. So our LCD in this instance is going to be x times x plus 3. So I'm going to write our original factored out. So we see 6 over x times x plus 3, 3 over x, 2 over x plus 3. We need our common LCD that we determined was x times x plus 3. So that is going to be our denominator piece for every single part. So we are missing nothing from the first one because they both have, the denominator here is the same as our LCD, so we're just going to slide our 6 down. Here we only have the x part of our LCD, so I'm multiplying top and bottom by x plus 3. So I'm going to write 3 parentheses x plus 3 in the top line. The last one, we are missing our x, so I'm multiplying top and bottom by x, so I'm going to write 2x. Since our denominators are the same for everything, that is our one fraction line piece at the bottom. So we have a 6, there's a plus sign, 3, x plus 3, there's a plus sign, 2x. And the reason I'm circling the sign changes is in case it happened to be a minus. We need to distribute in the middle term. So we have 6 plus 3x plus 9 plus 2x, x plus 3, x times x plus 3 in the bottom. Combine our like terms. I had $3 with an x, another $2 with an x. We have 5x. I had $6. I gained a 9. I have 15. Now here's where make sure that you can factor it out if you can reduce. So the top line, they're both factors of 5. So 5 times x plus 3 is what it factors out to be. And we have x times x plus 3. Well, in doing so, x plus 3 and x plus 3 cancels out, leaving you with only 5 over x as your final answer. Last example says, when we look at our situation again, there's 3 terms, 3 fractions. Simplified, simplified, not simplified, which here is difference of squares. So x plus 1, x minus 1, which happen to be pieces of your other 2. So your LCD in this instance is x plus 1, x minus 1. So we're going to write our original. We have 5 x plus 1 plus 6 over x minus 1 minus 10 over x plus 1, x minus 1. Again, we're going to convert all our fractions with a common LCD. This is what we're writing down for each of them. So x plus 1, x minus 1. Repeat it. Repeat it again. So in the first one, we have an x plus 1. We're missing our x minus 1. That is what I'm multiplying top and bottom by. So 5 times x minus 1. In the middle one, I am missing the x plus 1. So I'm multiplying top and bottom by x plus 1. So 6 times x plus 1. In the last one, we are missing nothing. So I'm just going to write the 10 down. Since our denominators are the same, I'm going to write one big fraction line with our common LCD. So we see 5 parentheses x minus 1. There's a plus sign. 6 times x minus 1 plus 1 with a minus sign. And then the 10 slides down. Where at this point, you need to distribute. We're distributing here and here. So we get 5x minus 5 plus 6x plus 6 minus 10. X plus 1, x minus 1. Combine our like terms. I had $5 with an x. I gained $6 with an x. I have 11 with an x. I'm short $5. I found 6. I have $1. But then I spent 10. I'm at negative 9. And then x plus 1, x minus 1. This does not factor. That does not break down. Here is your final answer.